Hello and welcome. I am Dr. Pauline Fu. In this video, I will demonstrate how to use Excel to do the simulation. So first, we are going to generate some random numbers. I'll open a new blank Excel file. So we are going to generate uniform distribution random numbers. So quick cell B1, type in uniform, and then type in B2. Suppose the uniform distribution has a maximum 70 and a minimum 10. So the formula for uniform distribution is rand opening closing bracket random number multiplied by maximum number minus minimum number plus minimum number, and then you copy down to generate 50 random numbers which have uniform distribution. 50, okay. Continue drag down. Until you see row 51, that is the 50 random number. Okay, so those random number has a uniform distribution with a maximum 70 and a minimum 10. The other way to generate this random number in uniform distribution is to use Excel data analysis tool. So I just type in C1 generation. So Excel data generation tool, go to data, and then data analysis. Click random number generation, OK button. Number of variables, just one variable. Number of random number, 50. Distribution, it is uniform. Okay. Between 10 and 70. Output range, select cell C2, and then click OK button. Okay, so this is another way to generate uniform distribution for random numbers. Another popular random numbers is in the form of normal distribution. So quick cell D1, type in normal. The formula is equal norm dot dist, opening bracket, random number, opening closing bracket, comma. Suppose the normal distribution has mean 60 and standard deviation 3. Okay. So not enough argument. Maybe I missed one parameter. Oh, missed one. Okay. Norm. Okay, so the formula should be, sorry, it is a norm dot inv, and then rand, mean is 60, standard deviation is 3. Okay, and then you just use the fill handle, double click the fill handle. Okay, so this is a use formula. Similarly, you can use the data analysis tool. Okay. So quick cell E1 and type in normal random generation. Normal random generation. Just use the short form. And then you go to data, data analysis, random number generation, click OK button. number of variables 1, number of random numbers 50. This time the distribution is normal. Okay, and you have mean 60, standard deviation 3, output range, you click cell E2. Okay, click OK button. So this is a random number, has normal distribution with the mean 60 and the standard deviation 3. Okay. So far we did creating random numbers. Next, we are going to do Monte Carlo simulation to simulate number of cars arriving at a service station. Okay, so this is the data file. Number of cars arriving per hour at the car washing station is observed for this number. Those are number of cars arrives, and those are the frequency. And you are asked to simulate 15 hours of car arrivings and compute the average number of arrivals per hour. And to do that, we need to do some probability distribution, create a discrete probability distribution. Okay, so first add all the frequency together. Okay, total number of cars, and then create a probability. So what is the probability? Arrive 3 cars. You use this number divided by total number of arriving, and then drag it down. When you drag it down, you have error because you should modify the formula. Every cell divided by B9, B9 should be $B, $9, absolute cell reference. Okay, once you change B9 to $B, $9, and then you drag it down, you get the probability. And once we get this probability, and we want to calculate cumulative probability. Okay. So the cumulative means the first one equal to the first one, the second one equal to this one plus this one, etc. And then you copy down the formula. Okay, this is the cumulative. And then you copy this data, Control-C, paste it here to create a select paste value only. Okay, and then this is your lower limit. This cumulative is actually your upper limit. So these two together create an interval. So for example, and you have to type in 0 here, the probability between 0 and not looks good. Let me see. So you copy, okay, the probability table from here. Okay, we can use this one. So we can use this one as our discrete probability distribution table here. The range. So the probability from 0 to 1 and the probability from 0.1 to 0.25, and those corresponding to this number here. So you copy this number to here. Later on, we'll use this as a lookup table. Okay, so next, let's simulate 15 hours of car arriving. So actually, we are going to create 15 random numbers. So type in equal rand, opening, closing bracket, and 15 until you see 26. That is number 15. no, row 25. So this is 15 random numbers. And now you are going to, based on this random number, look up in this table. If the random number between 0 and 0.1, number of car arriving is 4. If the random number is between 0.1 to 0.25, number of cars arrival is 5, etc. So we are going to use VLOOKUP. Quick cell B11, type in VLOOKUP, opening bracket, look up this random number. And this is my table array. This table is fixed, so you have to, when you use PC or Windows, you press F4 button to translate to absolute cell reference. I'm using the Mac, so I manually change to absolute cell reference. In this table, you are looking for row. This is column 1, column 2, column 3. So you are look up for this column 3. So number 3. And then you drag it, you just double click the file handle. Okay, and this is you simulated the 15 car arrivals. And next, you calculate what is the average of this number. So you type in equal average. And select this one here. So this is the average number. Okay. Next, we are going to compute the expected number of cars arriving using the expected value formula. So we are going to use expected number of cars arriving. So use these two columns here. And those are the probabilities. So remember the formula for discrete probability distribution is x times px add all. So this is actually in Excel, you can use a sum product. This number, this is array, another array. So this is the expected number. As you can see, this is a 6.35 and this is a 6.73. They are not big difference. If you simulate this random number many times, hundreds of thousands times, those two numbers are very close. Okay. So this is a simulation. In summary, in this video, I demonstrated how to generate random number based on a given distribution, random number, okay? And I also did the Monte Carlo simulation in situation for number of cars arriving, okay? So that's all for this video. Thanks for watching.